So proceeding on to the next question, that is your question number 22. An object of mass m makes n revolutions per second around a circle of radius r. Okay, so we need to find out the kinetic energy of the object. Okay, so suppose this is the circle, right? So this is the circle of radius. Suppose the radius of the circle is r. Okay, and the object is moving around the circle, right? So that means the object is moving around the circle, and suppose the velocity of the object at this point is v theta. Okay, so that means what will be the kinetic energy of the object? The kinetic energy of the object will be half into m into v theta square. Okay, so we need to find out your v theta, right? To find out v theta, we'll be using this information that the object makes n revolutions per second. So the object is making n revolution per second. Okay, so that means in 1 second the particle is traveling how much distance? N revolution, right? N into 1 revolution, right? N into 1 revolution, right? So I can write in this manner. So the particles in 1 second, it is traveling how much distance? N into what is 1 revolution? 1 revolution is the entire length that is traveled by the particle. Okay, so that means this will be equal to your 2 pi r. Okay, so that means in 1 second, the particle is traveling how much? 2 pi rn distance, right? So that means in 1 second the particle is traveling 2 pi rn distance. Okay, v theta is nothing but the distance traveled by time. Okay, distance by time. Okay, so what is the distance traveled? 2 pi rn, and this 2 pi rn distance is traveled in 1 second, right? So that means v theta is nothing but your 2 pi rn. Okay, so that means for here the kinetic energy will be half into m into v theta. What is v theta? 2 pi rn, right? So this will be equal to 2 pi rn whole square. So this will be equal to your half m. So over here if I just expand this will be 4 pi square r square n square, right? So if I just expand again, so this will be equal to 2m pi square r square n square. Okay, so that means the correct option to your question number 22 will be option number C, 2 pi square m n square r square. Okay, so proceeding on to the next question, that is your question number 23. And satellite travels around the earth in a circular orbit. What is true about the forces acting in this situation? Okay, so suppose this is the earth. Okay, so suppose this is E, that is the earth. Okay, and suppose this is the trajectory of the satellite. So the satellite is traveling around the earth. Okay, and this is the trajectory of the satellite. So that means over here I can say that the satellite is at this position. Okay, so that means this is the satellite. Okay, and the satellite is moving around the orbit around the earth with a velocity v. Okay, so this is moving at a velocity v. Okay, so we have to keep in mind that the centripetal acceleration of the satellite is always towards the earth. Okay, so that means the acceleration of the satellite is always there, and that is the centripetal acceleration, which is equal to your v square by r, where r is the distance between the earth and the satellite. Okay, and the force that the earth exerts on the satellite is also in this direction, right? Which is the force due to the earth and the satellite, right? So over here see that the direction of the force between the earth and the satellite is in this direction. Okay, and the centripetal acceleration is also in the same direction. The centripetal acceleration is v square by r, and the force that is applied by the earth on the satellite is F. Suppose the force be F. They are acting in the same direction, right? So that means what is happening? So we can say that the resultant force is in the same direction as the satellite acceleration, right? So that means we can say that the resultant force that is applied by the earth on the satellite, that is this force, that is the F force, this is in the same direction to the centripetal acceleration, right? Which is equal to your v square by r. right? So this is in the same direction. So the correct option to your question number 23 will be option number A. Okay, so let us explore the other options as well. The gravitational force acting on the satellite is negligible. No, we cannot neglect the gravitational force on the satellite. In fact, we say that the gravitational force on the satellite due to the earth is equal to G m1 m2 upon r square. Okay, so over here we can find that, so this is equal to G. What is m1? M1 is the mass of the earth. Okay, what is m2? M2 is the satellite, mass of the satellite, right? And what is r? The distance between the earth and the satellite. Okay, so this is equal to r squared. Okay, and this value cannot be ignored. Okay, so that means this option is incorrect. Okay, proceeding to the next option. There is no resultant force on the satellite relative to the earth. No, the earth provides a resultant force F. See, this is the resultant force that the earth provides on the satellite. Okay, so that means there is a resultant force on the satellite that is provided by the earth. Okay, so that means this option is also incorrect. Okay, proceeding to the next option, the satellite does not exert any force on the earth. So this is also incorrect. Why? The force that is applied by the earth to the satellite, okay, by the earth to the satellite, so this is equal to your G me ms by r square. Okay, so the same gravitational force will be provided by the satellite to the earth, okay, which will be equal to your same G me ms by r square, right? So in fact, in a way, you can also say that the magnitude of the force by which the earth pulls the satellite to itself, the satellite also pulls the earth to itself with the same magnitude, of force, right? So this is the basics of your gravitational force of attraction. See, when two bodies are placed close to each other, they will exert the same gravitational force on each other, right? So which will be equal to the same force, right? Which will be equal to your G m1 m2 by r square. Okay, so that means when two bodies are placed close to each other, they will exert same gravitational force on each other, right? The first body will give this force on the second body, and the second body will give this force on the first body, right? In this manner, the satellite is giving a force F on the earth. Similarly, the earth is pulling the satellite to itself with the same force, right? So that means the satellite does exist, okay, a force on the earth. So that means this option is also incorrect. So the correct option to your question number 23 will be option number A. I hope you got the question.